right, so today what we're going to do is we're going to review the first 5 chapters that we've covered up to this point. It's just to get you back into it after Christmas break, remind you of everything that we've learned, so make sure that you pay attention. This is not everything that we covered, but it's a lot of it, and there's going to be 2 videos of this. This is day 1, so we're going to be moving around the room and coming back up here for some graphing, so stay with me. All right, so the first thing that we did that was not basically a review was the absolute value. So all this is that they set this up and they isolated the absolute value here. So once you've isolated the absolute value in your equation, you can actually look at it and go, okay, well, how many solutions does this have? Because we understand absolute value is the distance from 0, and it can't be negative. It's going to come out as a positive number. So once you've isolated this, you look over here and you go, okay, is that a positive number or is that a negative number? Well, since this is a positive number, this is going to have 2 solutions. All right. If it was a negative number, it would have no solutions. And this is, again, just a reminder of what all we've already talked about. Okay. If you want more explanation about this, go back and watch the videos over all these things so that you get like full explanations of these. But just a quick rundown. Now that I know that this is a positive number, I need to know how to set this up. So I'm going to take this absolute value and I'm going to set it up in 2 different equations to find out my 2 answers that I have here. So my first one is negative 4y plus 12 equals 14. Nothing changed. I just dropped the absolute value and set it up as my equation. Up to. Sorry, I put 12. Okay, negative 4y plus 2 equals 14. All right, now I'm going to set up my second equation. And I set them both up before I ever work any of this so that I don't mess something up. All right, like that. All right, so negative 4y plus 2, that's the same. Okay, equals, again, is the same, but it's over here where we change. Negative 14. I changed the sign of this. All right, but now all I got to do is go through here and solve it, and I'm going to have my 2 solutions to this. And it's the same thing as solving, we're just solving for y. So add the inverse to both sides. Okay, leaves me with negative 4y equals 12. Divide by negative 4. Divide by negative 4. And you guys have done this a ton, so you should be very proficient with this. Okay, so y equals negative. A positive divided by negative gets me a negative. 12 divided by 4 is 3. So this is one possible, or this is one of our answers here. Okay? Now we're going to come over here and we're going to find our other answer. But it's the same process. Okay? Add the inverse. Okay? Leaves me with negative 4y equals negative plus a negative. Add, keep their signs. So 14 plus 2 gets me 16. Still negative. Divide by negative 4. Y equals a negative divided by negative is positive. 16 divided by 4 is 4. Now these are my 2 answers. My 2 answers, negative 3 and 4. Okay? These are my, I forget the term, but those are my answers that I'm looking for. Okay? Now, these are not in parentheses. These are in whatever this is. That. Okay? So that's what you're looking for. Those are your answers. And that's how you do that. Okay? Just pay attention to that. All right? Percentage change, tax, discount. Guys, you should know how to do this, but just to reiterate this to make sure that we go through this again, this is a life skill you need. So I wanted to hit on this again just so that you had it. All right, percentage change. The original was 36, the new is 24. We're looking to find out what was the percentage of this change. Was it an increase? Was it a decrease? What was it? Okay? So the way that you do this is the formula is new minus original over original. Okay, the other way to look at this is what's the difference of the 2 over the original, and then determine whether or not it was an increase or a decrease. Okay, both of them work. I personally like the difference one, but this does the same thing, right? So 24 minus 36, because that's the new, that's the original, over whatever the original was, 36. Okay? And now we're looking for the percentage, right? So 24 minus 36 gets you 12 over 36. This reduces down to 1/3, which is 0.33 repeating, okay? But we want a percentage of this. We don't want, oh, by the way, this is negative, right? Okay, because 24 minus 36 is negative 12 over 36, negative 1/3. So all this negative here tells me is that this was a decrease. Okay, that's what that tells me. So I know that all this was a decrease, but negative 0.33. But I want this as a percentage. So I've got a 33.33% decrease. That's the type of answer that they're looking for here. Okay? When they ask for what is the percentage of change, they're wanting you to say, oh, this was an increase or decrease of whatever percentage that it was. Okay? That's the way that we're looking for this. That's it. You got to know this formula. If you know this formula, you're fine. Okay? If it's a negative number, it's a decrease. If it's a positive number, it's an increase. Okay? You should be able to look here and see, just determine whether or not it was an increase or decrease though right off the bat. So there's that. All right, tax. Tax, you need to know how to do this. All right. So video game was $49. The tax rate is 6.5%. Remember, you got to take that percentage, turn it into a decimal. All right. So what you're going to do is you're going to multiply 49 times 0.065. 49 times 0.065. Okay, now I'm going to use a calculator because I don't want to do that. All right, so 49 times 0.065 gives me 3.185. So I'm going to take the 49, and because this is tax, when you're being taxed on something, you're adding that tax rate to the original number. So the original number was $49 plus the tax that came out of this, which was 3.185. We round it because it's money. We're talking about money. So add those together and you get 52.19. That's the total cost. That's how much it was. Now, if they ask how much was the tax, that's that. But if they ask what the total cost is, it's this. Okay? So pay attention, understand how they ask the question, because sometimes they're going to say, well, how much was the tax? Well, that's just this, the 3.19, that's doing this part. If they ask how much the total cost was, well, now you got to add that tax to this to get the total cost. Right? That's all you're looking at. Now, discount. You want to be able to walk into a store and determine how much you're going to pay, because you want to know what the original price is and what the discount is off of a number. So if the original price is $129 and it's 15% off, well, same thing, right? 129 times, turn that into a decimal, 0.15. So 129 times 0.15. Okay, so that gets me 19.35. But now we're discounting it. So we're taking this number away from the original one. That's what's going on there. Tax, you add it to it. Discount, you subtract it away. So we're going to subtract this from 129. Okay, so take your 129, subtract it away, you get 109.65, and again, that's money. So this is the discounted price. Okay? This was the tax rate, this was the discounted price. If they ask how much was the discount, there's the discount. Okay? That's all you're looking at here. As you need to know how to do this. This is a life skill. You gotta have that. All right, literal equations. Literal equations, you're solving for whatever the variable they ask for that you do. You do the same thing that you do when you're solving equations, except you're taking and saying, I just want this variable isolated, everything else on the other side. That's what you're doing. All right, so here, when they do this, solve for L. So we're solving for L. So P equals 2L plus 2W. They love this equation. Okay? They love that one. So P equals 2L plus 2W. You should recognize it too, by the way. And we're going to find the variable that they want us to solve for. Well, that's the L. So I'm going to move everything else over to the other side. Well, you deal with the thing that's furthest away. Plus 2W. Well, okay, let's add the inverse of 2W to both sides. So P, and you can write this in either one of two ways. You can do plus negative 2W, or you can do minus 2W equals 2L. So far so good, but I don't have this all by itself. I want to move that. So divide by 2, divide by 2, that cancels that out. And now I have P minus 2W over 2 equals L. All right. Now, some teachers want this flipped or whatever. I would accept this, but here, just so that they can see it, L equals P minus 2W over 2. Now that's how you solve literal equations. You just isolate the variable that they asked for. That's all it is. Everything else is the same. Okay, just pay attention to what's going on. Yeah, I mean, do the thing that's furthest away first. Yeah, you'll be fine. All right, rate of change. Rate of change and slope are the same thing. Whether they give you a table, a T-chart, they give you 2 points or a graph, you still need 2 points along that line in order to find it. Okay? Use your formula. If you are given a T-chart or 2 points, use your formula. Your formula, y2 minus y1 over x2 minus x1. That's your formula for slope. Rate of change is the same thing. All right? So you just need to pick 2 points. It doesn't matter which 2 points. I mean, you can use your intercepts if you'd like. You can use these 2 numbers if you like, so you don't have to deal with the signs. It doesn't matter, but pick 2 points and then be ready to reduce it at the end. Okay? That's all you got to do. So once you pick your 2 points, let's choose these. We'll show the signs. Okay? So here, I need to know this is my y, this is my y, this is my x, this is my x. And the key to this is setting it up correctly. Because once you get it set up, it's really not that bad. Right? So once I set my first number in there, everything else falls around it. Right? So y2. Well, here, let's put 3 as the y2. That's that one. If I put 3 right here as y2, my x that goes with this 3 automatically has to be the x2. So it's that. Automatic. Has to be. Minus minus, because that's the formula. And now I need the other y. 0 and negative 8. Okay. And now I'm just going to solve, right? 3 minus 0 is 3. Click, click right there. Negative plus a positive. Subtract, keep the sign of the bigger number. So 8 minus 4 is 4. The 8's positive, therefore it's that. Here is my rate of change. This is my slope. It's all the same thing. Okay? Use your formula. Now if you have a graph, use rise over run, but find 2 good points along that line, and however much you go up, however much you go over, to get to the next point. Okay? Remember that. Very important. Very easy, but very important. All right. Direct variation. Now, direct variation can be set up as y equals kx. K is your constant of variation, your rate of change, your slope, all the same thing. Why they use k, I don't know. But it's the same thing as all those others. Rate of change and slope, it's the same thing. Okay? Suppose you earn $127 for working 20 hours. Write an equation relating the earnings to the number of hours worked. All right. So time is your independent. Okay? It's always your x. So we know 20 hours is going to be our x, 127 is is going to be our y. We're looking for the rate of change. Well, since this is a direct variation, y equals kx, we get to also set up and look for our slope, or our k, by setting y over x. Now watch this. See, this is where those literal equations comes into effect. Look, how they got this. Y equals kx. They divided by k. Oh, I'm sorry. Oh, I lost what I was doing. No, I did the wrong thing. I divided by the wrong number. You divide by x because you want to solve for k. Sorry. How they got this was they divided by x. Now look. Y over x equals k. Isn't this and this the same thing? That's how they got that. They said, oh, we can set this up like this. And then if this is true, then this also must be true, because if we solve for k instead of y, we now have it where we can do this. Okay, well, the whole point of this is to say, well, we need to know what k is. Well, we can plug these in for our y and our x, because we know this is always our x, so this must be our y. So here we go. Our rate of change is 127 over 20. So k equals 127 over 20. Now you just divide that. 127 divided by 20, yeah, 6.35. So k equals 6.35. Now, guys, you could have left it in as a fraction. That works also. But in this instance, we want to know how much it is that you earn. So we're talking about money. So we need this 6.35 here. Okay. In other questions, depending on what it is, the fraction is going to be fine. Okay. In this instance, we want this money amount, how much you earn. Okay. So y equals 6.35 x. Well, what this represents is you're earning $6.35 per hour. That's what that represents. Okay, so having it as the decimal form here is important. Okay, in other questions you'll be fine with the fraction. Now, how much would you earn for working 35 hours? Well, okay, so y is how much you earn. 6.35 is how much you earn per hour. X is the number of hours. So we're going to substitute in 35. Okay? Now, 6.35 times 35. Y equals. So for 35 hours, I'm going to earn $222.25. Okay? This right here is important to understand, okay? Because you're going to see it a lot. So make sure you understand that. And being able to set this up, understanding like hours is going to be your x, okay, is really important. All right? All right. Just a couple more, but these are important ones. Graph, slope, intercept, graph using intercepts. Okay, so slope, intercept form, I should have said form, but graphs using slope, intercept form, and graph using your intercepts. So we're going to set both of these up and show you that, and then we're going to come back over here and write an equation for a line containing these 2 points. Okay, and we're going to use this. We're going to do this with a couple different things, so we're going to come back to that. But we're going to have the graph for this, so we're going to go up to the front of the board and actually show how to actually work these problems. Okay, so right here. This one we want to graph this using slope-intercept form. Well, slope-intercept form is y equals mx plus b. In order to do this, you need to know what the m is and the b is. Well, the b, now let's start with the m. M is your slope. It's your rate of change. It's how much you rise over your run. Okay, so this right here tells me how much my slope is. It tells me how my line actually goes. Okay. The b over here is your beginning. It's your y-intercept. It's where everything crosses the y-axis. And I call it the beginning because it gives us the very first point that we use in order to be able to actually graph. Because I know this is my y-intercept, I have my first point, 0, -2. because I understand that my y-intercept, the x, is always 0. Okay? And if I know that, now I can graph this line, because this right here is my slope. Well, we want to write it as rise over run, so we got to put it in as a fraction, so 4 over 1. So now I have my first point, and I have my slope. Once I have these two things, now I just get to come over here and start putting it onto the graph. All right, so here, 0, -2 is my first point. Well, here's the origin. 0 means I don't go any ways on the left or the right because that's in the x spot. -2 tells me to go down 2, so I don't go this way. 1, 2. Here's my first point. All right. Now, my slope tells me to rise 4 and run 1. So rise 4. 1, 2, 3, 4. Run 1. So there's my second point. And then I can keep doing this. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And now I have my line. Okay? Once you have your line, you're good. Because that's all it said to do, right? Graph using slope-intercept form. That's what it is. Okay? It's not hard, okay? But you got to understand a lot of things about this, right? You got to understand the one right in front of the x is your slope. The one right in front of your x is your slope. And this right here, this whole thing, is your y-intercept. Okay? So once you understand that, graphing this becomes a lot easier. Okay? A lot easier. All right. So now we want to graph this using our intercepts, our x and y intercepts. Well, we just talked about the y-intercept over here. What do we know about the y-intercept? We know that the x on it is always 0. So we know we're going to have one of these where the x is 0, and then we're going to find this other number. Well, okay, that's the y-intercept. But the x-intercept is just the opposite. It's where the y is 0. Because the intercept is about where the line crosses the x-axis and the y-axis. Oh, that's supposed to be 6. Yeah. Wrote my problem down wrong. Okay? So, but the intercepts, again, are about where the line crosses the x-axis and the y-axis. Right? So now that I have these, all I need to do is substitute these in for these numbers, right? So right here, the x is 0. So I'm going to take the 0 and I'm going to plug it in here for the x. So 3 times 0 plus 2y equals 6. Well, notice 3 times 0 is 0 plus 2y equals 6. 0 plus 2y, okay, these are our 0 property and our identity property, right? So 0 plus 2y gets me 2y equals 6. Divide by 2, divide by 2, y equals 3. Now look, what this says is that when x is 0, y is 3. 3. Okay? That's what that says. Because I plugged x in for here, solve for y, so when x is 0, y is 3. Now you do the same thing, except now you're going to substitute in the 0 for the y. Okay, same thing, same process. 3x plus 2 times 0 equals 6. Now, once you get good at this, you're going to realize, oh, well, so what this does is this leaves me with this and this. Okay, so 3x plus 0 equals 6. 3x equals 6. Divide by 3. Divide by 3. X equals 2. Okay? So again, what this says is that when y is 0, x is 2. Now I have 2 points here. Well, I can graph 2 points. All right. Let's go back over here to our graph. Let's see here. Should be able to go. There we go. All right. So we're going to graph our 2 points. 0, 3. 0, 1, 2, 3. and 2, 0, 1, 2, and now we have our line, okay? Your line, and you can extend it out this way if you'd like, okay? But you have your line, and you know what it looks like, right? And you can even find your slope from here to here if you'd like, okay? How much do you rise? 1, 2, 3. You went down 3. How much do you run? 1, 2. And you could take this back this way or this way, and you'd be fine, okay? Not a big deal. Really not as difficult as a lot of people make these out to be. Okay, so remember that. All right, so now what we're gonna do, we got just about one problem left, but it has really about 3 different parts into it. So write an equation for a line containing -4, 3, 1, 13. So you're given 2 points. All right, so when you're given 2 points and you want to write a line for this, a lot of times what you're going to use, first you got to find your slope. Okay, so you got to use your slope formula. Then what I like to do is I like to just put it into point slope form and then take it to whatever form they actually want from there. Right, so that's what we're going to do. We're going to use this, we're going to put it into our slope formula, put it into our point slope form, and then from there move it into slope intercept form and to standard form. So you got to know your forms, right? So first things first is slope formula. That's the one that we just talked about with the rate of change, so we're going to do that. So I'm going to label this as x1, y1, x2, y2. Okay, so 13, and guys, use this if you struggle putting them in the right spot, right? Label them first. 13 minus over 1, 3 minus 4. 13 minus 3, 10, click, over 5. This reduces to 2 over 1 or 2, okay? So my slope, my m equals 2, all right? Well, now let's put it into point slope form. Well, point slope form is this: y minus y1 equals m, parentheses, x minus x1. Now, here, it doesn't matter which of these points you use, because the x is going to go here, the y is going to go here, and the slope that we just found is going to go right here. Okay? Well, I'm going to use this one because it's the smaller of the two, and I feel like it's going to be the easier of the two. So that's what I'm going to use. So I'm going to plug in this here. So y minus 3 equals 2, and this is just substitution right now, x minus -4, parentheses, well, click, that becomes a positive, right? So now I don't need this, okay? So there is point slope form. That's point slope form. But if I want to take this point slope form and convert it into either slope intercept form or standard form, I can do that. So let's take this and turn it into slope intercept form. That's one of the ones, most common one, right? Okay, so it's all the same thing, right? Y minus 3 equals 2, parentheses, x plus 4, parentheses. Notice this is basically your distributive property set up for you. Distribute this 2 through. Y minus 3 equals here and here, 2x plus 8, okay? Slope intercept form is just solve for y, that's what we're doing, okay? Add 3, y equals 2x plus 11. Slope intercept form, y equals mx plus b. That's what it is, okay? Now, but let's say, okay, they said to go to standard form. See, this is slope intercept form, but if they said put it into standard form, well, the same thing, we still need to set up y minus 3 equals 2 parentheses x plus 4. Again, still in point slope form, and we're still going to distribute through. Y minus 3 equals 2x plus 8. Still have to do that, okay? Now we're going to start moving things around. Now remember, standard form is ax plus by equals c. That's what we're trying to go to. A, b, and c are integers. A cannot be negative. Okay? So, here, we're going to move this around. Let's add the 3 to both sides. Basically, I put it back into slope-intercept form, right? Y equals 2x plus 11. Now, subtract 2x from both sides. Negative 2x plus y equals 11. It looks like it's in standard form. However, standard form says that this number can't be negative. So we're going to have to take and switch this. And it has to be reduced all the way down, so watch that too. This is going to be reduced all the way down, but we've got to change it and change the negative. So we're going to multiply every term by a negative 1 on both sides. On both sides. So this becomes 2x plus negative y equals negative 11. All right, so now I look good here. There's another way that you could write this. You could also write it like this, 2x minus y equals negative 11. This is probably the most common way that you're going to see it. Okay, I'll accept this personally. I know it's the same thing, so I'm perfectly fine with this. But this is the way that you're going to see it on multiple choice questions. So be aware of that. Now, the only reason that I multiplied through by this negative 1 is because this number right here was negative. Okay, so that's the only reason here. I'm going to put this in parentheses so that you can see that that's multiplication. Okay, the only reason I did that was because this was negative. If this had been positive, I would not have done that. All right, so understand that, and there it is. But this right here, the skill, you're gonna have to be able to do this because they're gonna ask you to switch back and forth between forms. They're not gonna ask you to go to point slope form. We don't do that. We take and we go to slope intercept form or to standard form. But this is day 1 of our review. This gets us through a lot of it. If you have any questions on any of this stuff, let me know.